So if we continue in this section about logic, let's define an argument as a sequence of propositions, P1, P2 to Pn. So I have several propositions, okay? And then therefore Q. So the propositions P1 to Pn are called the hypotheses or the premises, and the proposition Q is called the conclusion. So the idea is I might have several hypotheses, and I wish to see, do they result in a logical conclusion, which I would call Q. Now, an argument is said to be valid provided that if P1 to Pn are all true, so if all of my hypotheses are true, then Q must be true. And if that's the case, then I say that I have a valid argument. Otherwise, the argument is invalid, or we might use the word fallacy. So what we want to do now is we want to take a look at a variety of arguments, and they have various names, and all of these go back to Latin words. Okay? But we want to determine the validity of some of these arguments. So determine whether this argument is valid. This is called modus ponens, or the mode that affirms. So my premises, I have two of them, are P implies Q, P. And I want to see, okay, does this conclude Q? So if I make a quick truth table, so P, Q, true, 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 false, false, true, false, false. Okay, so my first premise is P implies Q, or if P then Q. So if P then Q is true, false, true, true. P, I'm just going to recopy down the P column, so true, true, false, false. Now, I simply want to take a look at this first row right here. And I guess I could fill in the rest right here. Q, I'm just going to recopy down Q as well. Q was what? True, false, true, false. Now, in order for this to be valid, okay, if my two premises, I guess I'll call this premise 1, and here is premise 2, okay, for this argument to be valid, provided if these two premises are true, then Q must be true. So is there an instance, and I've got it right here in red, where both of my premises are true? Yes. Well, is Q also true? That would be yes. Okay? So it's important to note that when the hypotheses P implies Q, P are true, the conclusion is also true. Therefore, we say that the argument is valid. So in summary, I would say if P then Q, P, therefore Q. So an example in English would be, if you have a current password, then you can log into the network. Okay, if P then Q. P, you have a current password. Therefore, you can log into the network. And this is a valid argument based upon this modus ponens, mode that affirms, example. Okay, let's take a look at another example. So this one right here is called modus tollens, mode that by denying denies. And I want to see, is this a valid argument? So P, true, 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 false, false, true, false, false. Now in this one, I have two premises. I have premise 1, P implies Q. And then I have premise 2, not Q. So P implies Q, true, false, true, true. Not Q, so I'm going to negate the Q's. So this would be false, true, false, true. And then not P. Well, now I'm going to negate the P's. So this would be false, false, true, true. Okay, so I'm going to go through here at these two premises, this first premise and this second premise. Is there an instance where both of these premises or both of these hypotheses are true? Well, take a look right here. P implies Q is true, not Q is true, not P is true. So when the hypotheses P implies Q and not Q are true, the conclusion not P is also true. So we would say that this argument is valid. So if P then Q, not Q, therefore not P. So here, going back to this password and network example, if you have a current password, then you can log into the network. That's the whole if P then Q. You cannot log into the network, not Q. Therefore, you do not have a current password. So this is a valid argument, which we would call modus tollens. Let's take a look at another example. This is called hypothetical syllogism. So in this instance, I have two premises. P implies Q. I'll call that P1. And a second premise, Q implies R. I want to check, is this a valid argument? Therefore, P implies R. So I'm going to have a big truth table right here. Okay. P could be true, Q could be true. I could have true, false. I could go false, true, or false, false. And now I'm going to do another column for Q and R. Q could be true, R could be true. Q could be true, R could be false. False, true, or false, false. So let us write up P implies Q. So just looking at P implies Q, looking at this right here, P implies Q would be true, false, true, true. And now if I look at Q implies R, so I'm looking at these right here, Q implies R, this would be true, false, true, true. And now I want to see P implies R. Well, this would be true, false, true, true. So if I compare each of these, when premise 1 is true, premise 2 is true, then the conclusion is true. Also, true, 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 and true, true, true. So whenever P implies Q Q implies R, are true, the conclusion, P implies R, is also true. So we said this argument is valid. So in summary, if P then Q, if Q then R, therefore, if P then R. So here's a very basic example down here. We would say, if it rains on Friday, this is P, then the game will be canceled, Q. So P, then Q. If the game is canceled, that's Q, then it will be rescheduled for Monday. This is R. So if it rains on Friday, then the game will be canceled. If the game is canceled, then it will be rescheduled for next Monday. We can therefore logically conclude, if it rains on Friday, then the game will be rescheduled for next Monday. Therefore, P implies R. Okay, let's take a look at yet another example, which we would call disjunctive syllogism. So I want to determine if this argument is valid. Okay, so I have two premises, P or Q, which I might call premise 1, and then I have a second premise, not P. I want to see, does this conclude Q? So if I make a quick truth table, so true, 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 false, false, true, false, false. Okay, so P or Q, if I look at the truth table for P or Q, remember this is true if either of them is true and false otherwise. Premise 2, not P, so I'm going to negate P, so this would be false, false, true, true, and then Q, so I'm going to recopy down the Q column. So Q is true, false, true, false. Now, I'm looking here, is there an instance where both my premises, P or Q, not P, are both true? Well, take a look at this instance right here. So P or Q is true, not P is true. Does the conclusion Q also equal true? Yes. So we would say whenever P or Q, not P, are true, the conclusion Q is also true. So we would say that the argument is valid. So in summary, I would say P or Q, not P, therefore Q. Example in English, I might say, my pet is a dog or my pet is a cat. So in this instance, the P is my pet is a dog. The Q is my pet is a cat. Not P. My pet is not a dog. Therefore, you can logically conclude that my pet is a cat. So this is an example of disjunctive syllogism. Let's do another example. Determine the validity of the argument. This is called denying the antecedent, or we would sometimes call this in a mathematics setting the fallacy of the inverse. So let's take a look at these hypotheses. Okay? So I have two premises. If P, then Q. Not P. I want to see, does this conclude not Q? So if I make a quick table, so true, 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 false, false, true, false, false. Okay. P implies Q is true, false, true, true. Not P, so I'm going to negate the P column. So this is false, false, true, true. Not Q, I'm going to now negate the Q column. So this is false, true, false, true. Now, I need to take a look at instances where my premises are both true. So let's take a look at this third line right here. P implies Q could be true, not P could be true, and the conclusion could be false. But also, look at this fourth line. P implies Q, true, not P, true, and then not Q, false. So the point is because I got a false and a true conclusion for this not Q, this argument is invalid, or in math we might call it a fallacy. Okay? So when the hypotheses, if P then Q, not P are true, not Q may be true, that's this fourth instant right here, or it may be false. And so we would say that this argument is invalid. And so this is very important right here, okay? If P then Q, not P, does not conclude not Q, okay? In an example in English, we might say, if you are a swim instructor, then you can swim. You are not a swim instructor, that's not P, therefore, you cannot swim. Well, that would be incorrect. That would be an invalid argument or a fallacy to incorrectly assume that you cannot swim simply because you are not a swim instructor. So we would say that this argument is invalid. Let's take a look at one more. I wish to determine if this argument is valid. This is called affirming the consequent. So I have two premises. P implies Q. Q. And I wish to see, therefore, P. So if I make a quick table, so for P implies Q, this would be true, false, true, true. If I recopy down the Q column, that's true, false, true, false. And I recopy down the P column. That's true, true, false, false. Now, once again, I'm looking for instances where both of my premises, P1 and P2 are true. Well, here we have a true, true, and then a true. And then down here, I have a true, true, and then a false. And so I notice that if my two premises are true, then my conclusion might be true, or it might be false. So when, if P then Q, Q are both true, the conclusion, therefore P, may be true, or it may be false. And so this argument is invalid or a fallacy. So in summary, I would say, if P then Q, Q does not conclude P. And I like this example right here. It says, if an animal is a dog, that's P, then it has 4 legs, Q. My cat has 4 legs. Therefore, my cat is a dog. Well, clearly, this is invalid or this is a fallacy. And so we would say that this argument is invalid.